What is happening, guys? Welcome on back to another live stream where we are going to be taking a look at some random machine learning stuff because I couldn't think of a full end-to-end project to go for this stream. Now, I've got actually a ton of ML stuff that I want to share with you guys, namely tightening up some machine learning pipelines using Scikit-Learn pipelines. And we're also going to be taking a look a little bit as to some of the practice I've been doing over the weekend, namely around getting just like tightening stuff up using the custom transformer class inside of Scikit-Learn. We're also going to be doing a little bit of research on some new and upcoming machine learning models. We'll probably go through papers with code, see if there's anything interesting in that space. And we will also be taking a look at, if I had zoom on my camera, I'd zoom in right now. So I'm just going to do this. Stable baselines. Wait, not stable baselines, stable diffusion. Oh my God, I screwed up the punchline. Anyway, we are going to be going through stable diffusion and taking a look at what is happening in that space for image generation because there's so much cool stuff happening in the machine learning space. But before we do that, let me say hi to all of y'all. So, what is happening? Lakshman, how you doing? And Cora, how you doing? Pfizer, Sun, what's happening? Kevin, Venkatesh, please make videos on fine-tuning some Hugging Face model. I've actually got that coming up for a Code That challenge, so stay tuned. How you doing, Sarad? How you doing, Ronak? How you doing, Rahul? How you doing, Odin? How you doing, Ashley? Bali vlog. Oh, yeah, I know it's coming. How you doing, Wesley? Fraptastic. Is that... Frapastic. How you doing? How you doing, Physip? I'm learning math for machine learning. Yeah, I mean, it can be a little bit dry. I mean, also, fun story. It's lucky I'm still with you today here, guys. I was going for a run and... like, I like to power through, but I always stop at the edge of the road because I'm like, you just never know what people are going to do. So I stopped at the edge of the road. This car has come this way and has stopped to merge onto the main road. So they've stopped. I've stopped. They were stopped. I start running and I ran behind the car. And all of a sudden, this car starts reversing and literally almost took me out. Honestly, it was it was that close. No word of a lie. Lucky I'm still here. But anyway, I am still here. So we're going to be taking a little bit of a look into some machine learning today. And we'll see how we go. Google embedding challenge. Any plans to do that? Maybe, I don't know. Right now I'm just doing a whole bunch of random stuff and machine learning stuff that I'm finding interesting. Honestly, I'm finding that the more I'm passionate about something, the better I'm able to make content around it. Like the Google AI for Code competition was good, but I'm like, I wasn't passionate about it. So maybe I'll come back to it. We're definitely going to go back to the Forza one as well. Today, I just felt like doing a little bit of something slightly different and going through some stuff that I think is going to be useful because I'm flying out to Melbourne tomorrow for the API Days conference. So I'm going to be talking about a whole bunch of machine learning stuff, some cool stuff. The robotic process automation guys that I know that are down there, they've actually got the Boston Dynamics Spot robot. I think it's at the Gartner Symposium right now, but I'm trying to get them to let me play around with it. So who knows, maybe I'll get to do a video with that. How you doing, Mohammed? How you doing, Kitu? How you doing, Ronak? Have said hi. You should also start OpenCV live project streaming. Though they are already there, the way you make it and explains it. Yeah, I think I'm going to do some more OpenCV live stuff. I mean, you guys seem to really enjoy the latest Code That video. If you haven't gone and seen it, please do give it a like and let me know what you think. I haven't had this much fun making YouTube videos in a long time. Like, I'm really, really enjoying the Code That series. I'm planning to code a neural network from scratch. Any suggestions? Good luck, because pretty hardcore. There's actually a guy that I think has done it on YouTube. That is, like, I watched part of it and I sort of veered off, but he actually did a really good job. Oh, my shorts are the best. Keep them. Honestly, I'm trying to find ideas for shorts. So if you guys have ideas, hold up. Did you guys actually give me any ideas for shorts? Because I released a post. What was it, like this morning? Let me share my screen so you guys can see it. Did I release a post? All right, no, I haven't got any comments. If you guys have any ideas for shorts or what you'd like me to make shorts on, let me know. You know what's interesting? Like there was one short that I made. I think it was the regression one. There was like an automated regression one. And look, I really like packing in as much possible content into a video as possible, but it got to the point where I literally sped it, like there were parts that I sped up by like 1.4 times speed, and like the funniest comment is some dude in there was like, the comment was like, oh, Eminem been real quiet since this dropped. I literally cracked up. It was hilarious. Anyway, it's just a fun little story. I try to go through as many comments as possible. Even if I don't reply to them, trust me, I'm reading them. And I try to make content to respond to them if I can't get to them all. So that's why the object detection video is going to be redone at some point relatively soon. Or maybe I'll even make a code that video of it. So stay tuned for that. But all right, let's do a little bit of code practice. Also, another thing that I've been doing is I've been trying to... What have I been trying to do? I've been trying to just write or build a bunch of different types of models each and every day. Oh, we're getting a little bit of weird... hold up, let me turn these lights on. We're getting some weird coloring I should have prepared. We'll get rid of that. I think, yeah, that looks way better. Okay, so we are going to build... So I've got some data in here. So this is the Cloud Pack for Data platform that I tend to do a lot of client work on, and I've actually got a project that I'm working on with a client tomorrow to show some HR analytics. So we might be able to show this as well. So I think I've got a Kaggle data set which talks about how, like, predicting or employee churn. So this is just a data set that I've gone and uploaded into my project, and I've started and begun memorizing a lot more stuff for my data science pipelines. So let's just import. What I want to get a little bit better at is building custom transformation pipelines. So I started memorizing it. If you haven't watched the video that I did on how I memorize code or how I learn how to code, which is completely unconventional, doesn't mean it'll necessarily work for you, but it tends to really work well in terms of remembering stuff. So I was learning how to build these custom transformers on the weekend. So it's all from Scikit-Learn. So import or from sklearn.base import base estimator. And then we want to import transformer mixin. So these are the two classes I think I need. Okay, that's looking good. And then we can go class, preprocessor. And I'm actually tightening up a lot of this for right now because a lot of this is going into the course that I'm working on. So I'm trying to produce it in such a way that it's like really tight. It's just like something that I'm kind of proud to produce. Like I want to produce the best possible stuff for people that I'm going to produce content for. So I'm learning how to innovate on this. All right, so we've got this class over here. So this is like a custom. So if you've ever done any like one hot encoding with Scikit-Learn, so you can go from sklearn.preprocessing processing import. It's probably too small. Let's make that a bit bigger. Import what is it, like one hot encoder, right? So like I can import this one hot encoder, and if you actually take a look at the documentation, so we are actually building it up, or so they're using it from the base encoder, but I think that stems from the original transformer pipeline. Is it? I'm trying to find one that looks similar. Standard scalar. Yeah, see, take a look, right? So this is, so we're actually building a similar style pipeline over here to what is actually already instantiated for the for the Scikit-Learn pre-processing pipelines. Because you can see class, standard scalar, and then we've got self, and then we've got transformer, mix-in, base estimator. So we're effectively replicating a really similar thing to what you've already got inside of the other Scikit-Learn pre-processing pipeline. For anyone that is super new to machine learning, actually, let me jump to the breakdown board and give you a little bit of a breakdown as to what on earth I'm doing. Because if you're new to this, you're probably like, Nick, you're just speaking gibberish right now. I got no idea what you're talking about. All right, cool. Breakdown board worked first time. Works 60% of the time, every time. All right, cool. So if you think about machine learning, right? So let's say I always do data in green because I just think of Excel. So we'll have this, it's a bit too small. Let's make that bigger. Where's the undo button gone? Down here. The right pen. A technical pen. All right, so this is our data set. Yeah. We're just going to call this CSV for now. Now, whenever you're doing machine learning, right, like you typically take this. Can you see that fully? Yeah, you can. You typically take this and push it through a pipeline. And I always remember, the way I remember this is like a Mario pipe, right? That's going to be the pipeline. And then like imagine Mario jumping out of that. So that pipeline is going to contain a bunch of different types of things. It might be filling missing values. We'd call it NA. We might do some scaling. We might drop columns. We might do a ton of stuff. The beauty of using this class and the reason why I do it is because it just keeps it in a uniform pattern. And then when you go to save this model, it's going to maintain that pipeline step. You don't need to go in, bring it in separately. You don't need to go and apply it separately. As long as you've got that custom class imported inside of the same script, it's just going to work. And it keeps things really, really, really nice. So, yeah, so effectively, rather than say like, so traditionally, let's say I built an XG boost model, right? And if I use like joblib to save this down, so joblib is just think of it like saving a particular package, right? Or like saving something. So similar to how you save your Word documents, you'd use joblib or another library called pickle to save your machine learning models. If we were to go and just save this model here using a package called joblib, wow, that looks so messy. Let's just do that. So if we were to save this into here, we would be saving our machine learning model only. Now, if I go and apply the pipeline over the top of it, so remember Mario, I'm not going to risk drawing Mario because I'm going to completely butcher it. It's going to save all these, it's going to save all of these pre-processing steps. So everything is all nicely packaged up. Let's draw a little, nope, needs to be purple. So just think of it as a nice little package. I'm going to draw a present with a bow on top. That's as good as my package drawing skills are going to look like. This is a package. You get the idea. Anyway, so the beauty of doing it like this is it just keeps things a lot cleaner, a lot nicer, a lot consistent, a lot more production-like. Alrighty, cool. So what have we done? So let's keep building our pre-processing pipeline. So self, and then we're going to go x, and then y equals none. So I literally learnt this weekend, and then we're going to return self. So that returns the trained pipeline, and then def transform, I believe. Wait, no, this is not def init. This should be def fit. This should be transform, and then we go self, and then x, and then y equals none, and then we do whatever transformations that we want here, and then we typically return x. So that is going to be our base pipeline, right? So this is the fundamental architecture or fundamental structure of one of these classes. So you've got a fit method and you've got a transform method. And then, so let me show you how this would work. So let's say I've got this big data set over here. And let's say there's certain fields that I don't really need. Well, we know attrition is going to be our target. So I could actually immediately go and say that, so x equals df, and then I've saved it as df, yeah? df dot drop, and then it'll be attrition, axis equals 1, and then y would equal df, and then attrition. Right, so that's our data set. That's our x set, and then, or our x, effectively our target features, and then this is going to be our target. So x is our input features. Input features. We won't go through this entire thing, but I'm just doing a little bit of practice to show you guys what I've been learning as well. And then y is, what's y again? Y is our target variable. Variable. And when I first started, it's funny, right? Like when I first started with machine learning, like this wasn't really talked about all that much. Like it's talked about in Aurélie Géron's book, but like if you think about like a lot of other processes, like there's not a lot of emphasis is placed on building a nicely packaged pipeline. I personally think it's really, really important, particularly when it comes to deployment, because deployment can be an absolute nightmare if you've just got dependencies floating around everywhere and you don't have stuff structured nicely. Okay, so the way this would work, so let's go and transform a column, right? So let's say we just wanted to, so we've got a ton of different columns. Let's see if we've got any missing values. Let's just say we wanted to drop NA or x.isNull.sum. All right, we got no missing values. Wow, so this data set is great. All right, so let me let's think of another one. So let's just say, for example, we wanted to drop, I don't know, the business travel column and the daily rate column. So what we would do is we would actually go inside of our transform. We would go x equals x dot drop, and then the columns that we want to drop. So like, for example, daily rate, right? We'll drop daily rate, and then we drop business travel. And then axis equals 1. And then we would return x, and then that should be, so this obviously doesn't have a fit component. We don't actually need to go and fit anything, but if we were going and doing like any imputation, we could actually go and fit our like simple imputer. So let's say, for example, I went from sklearn.impute, import simple imputer, right? I could actually go and instantiate this simple imputer here. So I could call self.imputer equals simple imputer. Simple imputer. There we go. And then I could go self.imputer.fit, and then I could pass through x that way. And then down here, whenever I needed to go and reload my pipeline, I would then just need to go self.imputer. Transform, right? So then I could pass it through like that. I obviously don't have any missing values, so I don't need to go and impute anything. But the beauty of this is that when I then go and look at this pipeline, so if I go and bring up preprocessor pipeline, and actually go and fit it, it would actually give me those two different types of steps. Now, I'm going to drop this just so you can see what it actually looks like. So I don't have to do anything in fit, so I can return self. Let's get rid of this. Nope, I don't want a question mark there. We want to comment that out. And then we would go, so preproc. Now, the way I used to do this is I would just actually add all of these steps to a separate, effectively a separate function, and then I just run it like that. But now I'm like tightening this up a lot. I could go preproc now, and then preproc, and then pass through our x values. No, dot transform. Right, and look, it's actually dropping those columns that I just described. So it's dropping the daily rate column and business travel column. Now you're probably thinking, Nick, I could not care less what you just went and did. But the beauty of it, and I know I'm a sucker, I've got massive OCD, but we can now go and pipe this into a pipeline. So I can go from sklearn.pipeline, import pipeline. And then if I go and make that pipeline, so I can go ML pipeline. Full disclosure, most machine learning engineers or data scientists are now using pipelines, right? So I can go pipeline, and then I can add in each of my different steps. So I can go, this is going to be my pre-processing step. And then I actually pass through my pre-processor pipeline to that. And then let's say, for example, I wanted to go and use XGBoost or like some other hardcore machine learning model. I can go from XGBoost, import, what do we want? Like it'll be XGB classifier. Right, so then we can go and plug our XGB classifier into that as a separate step. We need to wrap this inside of a tuple, and then another, and then we'll go XGB. And then it'll be XGB classifier. My head's not covering that. Boom, how are we looking there? Cool, then I go ML pipe. And you can see that I've now got each one of my steps. So I've got my pre-processing step, I've got my XGB classifier step. Now, I don't know if we need a one hot encode by default, but I could go .fit, pass through X, pass through Y. Probably going to get errors because we need to one hot encode. Yeah, we need to go in one hot encode. But effectively, that is how you'd be able to do this. So what we'd actually go and do then is we'd go and import, probably veering off now, from this being a simple what's called a simple tutorial, but we'd go from sklearn.compose, and then we'd import the column transformer, and we'd actually import the one hot encoder. It's not from impute, it's from preprocessing, one hot encoder, and then we'd import, what was the other one? Standard scaler. All right, so we then go and take everything or the specific columns that we want to go and one hot encode, and we'd go and add them to our pipeline before it gets to our XGB model, right? So I would then go ML pipe. No, we want to go and check our data set. So x.select dtypes. X.select dtypes include equals object. So this should give me the columns that I actually need to go one hot encode. So you can see one hot encode, these are all categorical, majority of them are. So then I can go dot, what are we doing? So dot columns. So these are going to be the categorical columns. And then we're going to do the same, but we are just going to exclude our categorical columns. So numerical columns, and then we're going to type exclude here. So we've effectively got two variables now that encapsulate our categorical columns and our numeric columns. Boom. Take a look at that. Magic. We should also, yeah, we don't have our Y value in there. Okay, cool. And then we'd go and create, so we've got our pre-processing pipeline. We then go and create two additional pipelines. So categorical pipeline, and then a numeric pipeline, numerical pipeline. Yeah, we'll call it that. And then we would go and make our pipeline. So pipeline, you're going to probably be sick and tired of me saying pipeline by the end of this, but we'd go and apply our one hot encoder to our categorical pipeline because that's what we need to do. So I'd go one hot and then one hot encoder over here. And then for our numeric, we'd go and build a pipeline, and then we'd go and say that we need to scale. And then we'd go and apply a standard scaler pipeline over here. And then we'd combine them all. So the beauty of it is that the column transformer, what do you call it? The column transformer pipeline allows you to bring all these back together. So then we can go and call it transformer pipeline equals column transformer. And then we're going to bring all these bad boys back. So we then need, I always forget how, I think it's an array. And then we actually go and say, so we're going to add in two pipelines. So the first one's going to be called cat for categorical. We pass through the categorical pipeline. We then pass through the categorical column names. And then to the next thing is the next part, which is the numeric pipeline. And then we're going to call through the numerical pipeline and then pass through the numerical columns. I think that's okay. No errors. I should probably bring this up. This should come up. Let's throw this over here. Boom. What does that look like now? Transformer. That looks all right. So you can now see that we've got this transformer over here. Let me zoom in on that. Can you see it? So we've got a categorical transformer pipeline, which is going to go and apply a one hot encoder to these specific columns. Kind of beautiful, right? And then we've got a numeric pipeline, which is going to apply standard scaler to these columns over here. It's just so nice and structured. It really appeals to the OCD part of me, but it's just nice. Nice. Okay, cool. So that is our transformer pipeline, and then we got to bring it all together. So then we'd go and apply our This is the beauty of it. Right now, I just throw it into my pipeline, my full-blown machine learning pipeline, and we're going to call this one transformer. Robots in disguise. All right, sorry, my bad. Couldn't help myself. And then we're going to go and pass through transformer pipeline over here. Look at this magic. And then go and take a look at our ML pipeline. So now we've got our pre-processing. So that's our custom transformer. So that allows us to drop columns, create custom features, do all the magic that we need to. We've then got our column transformer, which is going to apply a one hot encoder to our categorical columns, and then we're going to apply standard scaler to our numeric columns, and then we're going to go and apply our bad boy XGB classifier over the top of it. How cool. Sick, right? Okay, there's one additional thing that I do need to go and apply though, is we need to we need to handle unknown, and I just set ignore at the moment. So this ignores any hot encoded features that it's never seen before, so it'll just skip them. So otherwise you do get errors, but it's be very mindful that you do need to pay attention to the specific values that are coming into your machine learning pipeline. Very important. Although I'm just being a little bit lazy right now and skipping through that. But what you would actually go and do is you'd ensure that the categorical features that you are training your model on are very similar or identical to the population, the entire population that you are likely to see out there in the wild. Anyway, that's our machine learning pipeline built. Now we should be able to fit it. X, Y, still getting errors. What's happening? A given column is not a column of the data frame. Is this because we have gone and dropped? It's because we've gone and dropped these two columns here. So what we should really do is, rather than having, I'm just going to say, yeah, well, I'm going to drop them over here. So it's okay. So these are going to be, let me take a look at these columns to begin with. So X dot head. See, this is me trying to, so daily rate is a numeric column. So exclude object. So I'm going to say dot drop numeric axis equals 1. This is overkill just to prove a point, but I'm just sort of showing because I can't help myself. So no, hold on. This is not drop numeric. This should drop daily rate. And then we want to drop department over here so that it is going to not expect them. So the reason that this is occurring is because in the preprocessor pipeline happens before our other two steps. And right now we're telling our column transformer that we're expecting those two columns when we want to go and apply that custom transformer. So that's just a thing to note. Now I'm just dropping them here just to handle that error, but you would typically not do this. You wouldn't just drop a random set of columns just for the sake of it, for funsies. Okay, so that is that. And then that's our transformer pipeline. So we'll just make sure that we don't have daily rate and business travel in these over here. So we doesn't look like they're there. Wait, hold on. Business travel is there. I've dropped the wrong columns. Hold on. Daily rate and business travel. df.head. Daily rate and business travel. I've dropped department. So business travel should be dropped from the categorical pipeline. Business travel. Boom. Okay. That looks better. Now, run it. Okay, that looks good. So this is now training our XGBoost model. Magic. Machine learning in a nutshell, guys. So that's training now. But that effectively shows you how to go and structure a ton of machine learning pipelines together. Delete all that. Delete that, and then we'll probably go, really should have saved it in a variable. Oh, well, we're going to have the ML pipe, so I can then go ML pipe dot predict and then pass through X. We should have set up a train test split. We'll do that in a sec. Cool, but that's our machine learning model trained. Anyway, I figured I'd show you a little bit of that. Bit of coding practice. Let's go and check the chat. Check the chat. I'm going to have to trademark that. I really do like that. Alrighty, what's happening? So, have I tried the Windows terminal? They're pretty good personalization options. I haven't actually. Hi there, I've got a problem with reinforcement learning Kaggle. Practice at Kaggle. Looking forward to the live stream. Love having you all here. Is there any feedback I'd give to beginners in machine learning? Yeah, I think just give it a crack. Start. So don't be afraid of the fact that everyone's telling you learn this, learn that, learn. I just honestly go and learn how to use NumPy, how to use pandas, how to use Scikit-Learn, and give it a crack. So the sooner you get started, the sooner you're going to be able to start having fun with it and trying it out. So don't be afraid. Don't let anyone scare you off. Just get into it. I think I held off starting for so long because I was like, there's so much stuff I need to go and learn. And I didn't go and learn, but now I'm just like, you know what? If I want to go and learn something, I'm going to go and learn something. Nothing's going to stop me. And that's what I really would like you guys to do as well. So if you're a beginner. How you doing, Phil? Yeah, I know the chat is a bit delayed. So I just can't do it. It's because my net, the latency kind of sucks. Thanks for the great content. Yeah, no, the live streams always go up afterwards, guys. They're always straight up on the channel. You can check them out. No data visualization. I'm being a little bit lazy in this one today. Yeah, I dropped the wrong column. Good pick up, Ari. Is there any way for us to see the code live? Yeah, normally I throw it up afterwards. But yeah, cool. All right, that is part 1 of the live stream done. And now let's go do a little bit of magic with Stable Diffusion. So I set this, what did I do? So like the majority of this code is from the Hugging Face website, and I was playing around with this week because I want to go and do a code challenge with it. But the beauty of it is that, so you probably would have seen me doing a bunch of DALL-E videos or live streams, but obviously it's a bit of a nightmare to go and get access to DALL-E, right? You need to go and apply, no definite chance that you're actually going to get access to it. This is where Stable Diffusion comes in. So this was built by a company, I believe it's called Stability AI. Yeah. So these guys went and built Stable Diffusion, which allows you to make amazing stuff like this using open source code. How sick is it, right? Now, I went and created, or I kind of hacked together some additional code. Part of it is from the Hugging Face repository. Part of it, just the visualization bit, I've gone and written down here. Mainly just the plotting, like all credit goes to the Hugging Face guys. But take a look. So this is the prompt here. So a Porsche racing a Ferrari in a drag race. If I pass through that prompt and then go and run this, I hope I'm still connected to the kernel. But take a look. Boom. It's created this Porsche as a Ferrari, I think, but you sort of get the idea. Now, guys, give me some prompts. What else do you want to see Stable Diffusion create? So, what is this? Like, what prompt would you pass through for this? Got to give me some user-generated image using Stable Diffusion. I just want to know what they type. I'm not creative enough to know what on earth to write for this, like, I don't know, knight in shining armor? An old school knight in shining armor. Sheep in space wearing sunglasses. You got it. We're going that one next. Oh, dude, that's actually pretty sick. All right, we're going with Lakshman's suggestion. So, sheep in space wearing sunglasses. He's not quite in space, but he's definitely wearing sunglasses. A sheep in let's say outer space. Deep outer space. Let me zoom out a little bit. There you go. There's your sheep in outer space wearing sunglasses. I get so amused by this, but it's like literally like state-of-the-art amazing machine learning that is behind this. A snowboarding cat on a lava stream. I wonder how this compares to the stuff that DALL-E 2 creates. There you go, snowboarding cat on a lava stream. Guys, that is sick. What was the sick one that we had? So I know we did, where do we do some DALL-E 2 ones? DALL-E 2, DALL-E 2, DALL-E 2. I can't even remember where on earth. Let me just turn the volume off. What's flying toasters? Oh yeah, did some sick Egypt ones. What is ancient Egypt civilization drawn with the cyberpunk theme? Ancient Egypt. Oh gosh, typing EGY civilization drawn in a cyberpunk theme. Guys. As if that is not sick. What if I do it again? Dude. Honestly, this is so cool. What was another... Could have sworn we asked for like... There was a ton of hilarious ones. DALL-E 2. Wait, no, DALL-E 3? How do I find the old community tabs? Wow, I probably post way too much on the community tab. Oh, here we go. Oh, there was a ton. Where were they? So it was just, I just saw it. DALL-E 2. DALL-E 2, DALL-E 2. Oh, I think it was actually during the live stream that we had them. Anyway, give me some other ones, guys. All right, F1 race on the moon. Let's say Formula 1. One race on the moon. There you go. What does guidance scale do? Hugging face. What are we doing again? Stable diffusion. Guidance scale. Guidance. This is how I learn. I literally Google half the stuff. All right, besides number of inference steps, we've been using another function argument called guidance scale in all previous. Guidance scale is a way to increase adherence to the condition signal that guides the generation text, as well as overall sample quality. Is known as classify. All right, so values are usually good choices. By default, the pipeline uses a guidance scale of 7.5. If you use a very large value, the images might look good, but will be less diverse. Okay. So if we use a lower value, we'll get really diverse images, but they might look crap. Okay. All right. So, I mean, what if I set 15? Chubby puppy eating cakes on the beach. Oh, gosh. Oh, yeah. Hoodies in the code, that collection. It's coming. I got to go. Is this what you want on the hoodies? Well, I'm gonna hold off, but let's what else we got? There we go. All right, let's try this next one. Who's this coming from? Yeah, let's do Angel's suggestion. Angel. So a rabbit, sorry, my bad. Rabbit coding in a subway. Yeah, so this was a guidance scale 15. So this will produce, I don't know where the rabbit is, but that's the subway. So hold on. So guidance is the adherence to the text. So that means, what if I increase it by a ton? 100? Hold on. Am I getting more than one image out of this? If I just... Hold up, let's do a little bit of magic here. How many images does this actually generate? This looks like it's generating more than one. Potential and not safe for work content. Oh, okay. Image. I think it's still just generating one, right? Yeah, it's only generating one. So I think that guidance scale is way too high. So is there a scale? What's the region? Let's drop it back down, 7.5. Also, I'll share this code if you guys want it. The majority of it's available freely on the Hugging Face site. There you go. Well, you got a rabbit in a subway. It's not necessarily coding, but that actually looks like hyper realistic, right? I mean, it's a weird bunny, but definitely a rabbit. You didn't specify real or fake. Chubby puppy eating cakes on the beach. Right, yeah, let's try that one. All right, Ash. There you go. It's not eating cakes on the beach, but you've got your chubby puppy on the beach. This one actually is hyper real. Guys, can you comprehend how sick this is? This is literally me passing a bit of text to an AI model and it is generating this. It is creating it. How awesome is that? Seriously, honestly, it's so sick. All right, international space. Yeah, Kenneth, this is Stable Diffusion. Bad boy up here. You got to get an API key from Hugging Face, but you can do it. Like it's openly available. It's just to authenticate. I'll probably get limited at some point, but looks like a post-cake photo. Oh, dude, this one is like hyper accurate, right? So this was coming from Lakshman, like an International Space Station getting hit by an asteroid. That's what I'd expect it to look like. Pretty sick, right? Oh, this is just nuts. Like, I honestly find this so cool. Let's find some great prompts. Good prompts. Prompt examples for DALL-E 2. Here we go. Inspiration examples. Sand sculpture. Let's do that one. Sand sculpt. C-U-L-P. That is T-U-R-E. I've been playing a lot of Pokemon lately. Sand sculpture of Mewtwo. It's my Sunday guilty pleasure of Mewtwo fighting a... Oh, what's that other Pokemon I caught? I can't even remember. Oh, Pikachu. I don't like Pikachu. Sorry, guys. Old school Nick. There's always like blitzing everyone and Thundershock. Like... Okay, not what I was expecting, but there you go. There's a sand sculpture of a Mewtwo fighting a Pikachu. Think we're done here. Anyway, let's go. What else? Hyper realistic pencil drawing of what? Generate a random image. Random image. There's your random image. What else do we get if we keep pushing it with this? There's a random image. That's random as hell. This is kind of cool. All right, what else we got? Ooh, I don't know. That one's a bit. I was getting a little bit post. What do you call that? Abstract postmodernism. Never that great with art, but that's what I'm going to interpret it as. Man, my art teacher hated me. This is why I'm a coder now. I was clearly not inspired enough. Watercolor of a man sitting by a fire playing a guitar. I like that one. Thank you. Ilka Galip Attack. There you go. I don't. There's no fire, but it's definitely generated an image of a watercolor man playing a guitar. What if we did another one? Oh, come on, guys. Are you saying this? Like, seriously, as if that is not brilliant. This is open source. Nuts. Does it do style transfer? I haven't tried. I don't know if it can do style transfer. I didn't look into it. An ant beating on Batman. I feel like this was guys, do you remember the A dog getting stung by a bee. Oh god. If you didn't watch that stream, god, I'm such an idiot. Anyway, there you go. An ant beating up Batman. Oh, it's even generated the text. I don't know where the ant is. Is that the ant there? Let's try out another one. Pineapple on pizza. You know what, guys? I think I'm a convert. I think I'm actually a pineapple on pizza person. I know. This is like Batman as an ant inside of the collab logo. This is meta now. Is it like looking at what it's generating through and then just generating or taking inspiration from that? All right, what else we got? Let's actually try Batman riding a go-kart. I got Pokemon with this prompt. Pokemon Mewtwo. I'm going to try that. There you go. Batman riding a go-kart with no hands. Look, Mom, no hands. Honestly, as if that isn't pretty cool. Pokemon Mewtwo Unreal Engine 8K. I want to see if it generates. This Batman is pretty sick, though. I kind of want to save this. This is sick. Batman. So this is Pokemon Mewtwo Unreal Engine 8K coming from Kenneth. Oh, dude. It's Pikachu. Did we say Pikachu? It generated Mewtwo. Generated Pikachu instead of Mewtwo. What if I said Charizard? It's a weird-ass Charizard, but it is a Charizard. There you go, guys. Add Canon 50 for photographs. Ooh. What if we did that? Because I guess it's interpreting that that's an image from a camera. There you go. That's what a Pokemon would look like if taken from a Canon N50. What if I did Sony A7C? That's what we're live streaming on right now, at least that camera over there. There you go. Sony picture quality, clearly a little bit more cartoony than a Canon camera. Alrighty, cool. All right, let's do it. Fine, we're gonna do it. Amber Heard's dog. So my dog getting stung by a bee. Fine. Make fun of me again. Dog getting stung by a bee. I don't watch the news. Oh, this one actually looks pretty realistic. We don't have the camera on it. Oh, what if I said 8K? This is a dog bee man. All right, there you go. All right, we're going to do one more, and then we are going to be wrapping it up. All right, I've already seen it. Darth Vader doing a bench press, and then we are... All right, so we've got to be. All right, this is the last one, guys, and then I'm going to wrap up and go eat. For once, I'm probably not going to eat pizza for dinner. Although I tried being really healthy last week. I was having kale smoothies, and I think I got an allergic reaction on my legs. So, I mean, maybe there's something to it. Maybe pizza is the way. It's the ultimate high-performance coder diet. Anyway, that's Darth Vader doing a bench press. Let's do it. Maybe if we increase that guidance scale, we're going to get a dog bee. Oh, gosh. It's coming back to haunt me. Hey, look, he's in the position. There's just no bench press bar. He's doing like that. That's some serious like CrossFit parkour style over there. Like Actually, that's like the Michael Jackson lean, just like leaning back. Wait, he leans forward. What if we do that? Let's increase it. If I bump it up to guidance scale 8.5, do we get closer? Oh, he's clearly got a like a spaceship style bench press machine there. Hold up, one last one. I know I said last one, but I'm gonna do 3 last ones. So this was with the guidance scale increase. All right, this is just Darth Vader shaking Darth Vader's pen. It's like that's the Spider-Man meme. It's like, alrighty, cool. We are wrapping this up. Ooh, Kevin, could I please make a vlog about the conference that I told us about tomorrow? I wasn't going to, but okay, all right. I'll bring the vlog cam along, and then I'll make a vlog. I've still got the Bali vlog to edit. My girlfriend's. I promised I'd make it for her birthday, but just taking a little bit of time. Plus, editing is. All right. Actually, I've seen a really interesting question. What do I think about the copyright and ethical problems of this model? Is it possible to generate images of violence? I don't want to try that on the stream because I'm all about positivity here, or at least trying to get back into a good positive mind space. But copyright and ethical problems, I don't know. I really need to think about it. But because it has been trained on a ton of models, it would really depend on what the source of those images are. Because obviously it's generating influence from, but this is only going to become more of an interesting problem as we go into the future and as we get these huge models. Because even though this is to do with generating images, what's to say that we don't have the same issues with the models like GPT-3, which have obviously been trained on people's code, or the Codex model, which is generating code. And like you can clearly see that that is inheriting some style from other people, and it's obviously generating code from people's GitHub repositories. So I don't know, it raises the same question. I haven't really thought about it too much, but I just try to use this stuff in a good way, or my ethical framework. And I tell people this all the time whenever I'm deciding whether or not to do something which may cross the boundaries. I always think about, if my grandma saw me doing this right now, would she approve or disapprove? Would she be happy or not happy? And that's sort of what guides my moral compass. And my grandma's a great person. She's gourmet in my heart. Anyway, that has been today's live stream. We've gone through it. Oh, wait, hold on. We've got one more question. Nick, do you think that it is a good idea to start working as a software engineer in a cloud computing team and then get into ML? Honestly, I think working as a software engineer with machine learning is way more fun than just doing strict data science machine learning. Because you get, like, there's just so much other stuff. Like, machine learning is a feature and a function into this stuff, and there's nothing to stop you from getting deeper. But fundamentally understanding the concepts of software engineering, as well as having a good mathematical background, there's nothing stopping you. The world's your oyster. You could definitely go and get into AI. But on that note, we are going to be wrapping up. Thank you so much, guys, for tuning in. Hopefully you've enjoyed this one, taking a look at pipelines and stable diffusion. Maybe we'll talk about some of those other machine learning models that are coming up in a couple of days. I'll catch you in the next one, guys. Have a great night. Keep coding. Peace.